This is the podcast for Physical Science 8th grade, 3.3 Gravity and Friction. All right, the very first part that we're going to cover is what is gravity. So the gravity is the force that objects exert on each other because of their mass. So again, this is the force that acts between two masses. These two masses attract to each other, and gravity is considered that universal force, right? Because it acts between the two masses, and it doesn't matter where in the universe this is happening, they're going to always be attracted. The strength of that gravitational force, though, is going to depend on two things, and that is mass and distance. So the greater the mass, you're going to get a greater force, such as you see here in this picture. You see two small balls. There's not a huge gravitational pull between them. However, if you have a large ball and a small ball, these are going to have a greater force because of the total mass is greater than that of the total mass of the smaller ones. When it comes to distance, the greater the distance results in the smaller force. So in this case, if you have two items that are closer together, they're going to have more of a gravitational pull than those that are further away from each other. So Earth's gravity, it exerts a downward pull on any item. If I were to drop a coin, it's going to pull that coin down towards the Earth because of the gravitational force that is acting between the two items. Now, if I were to do this in a vacuum, remember a vacuum is a space where all air particles have been removed from the area. It's completely empty space. What happens is if I drop two items, they're going to fall at the exact same rate. No matter what the mass is of either item, they're going to have that same amount of acceleration pulling them down because of Earth's gravity. Let's talk about how mass and weight are two different things. Mass is a measure of how much matter an object contains. Mass is a property that an object has no matter where it is located. Weight, however, is the force of gravity on an object. Depending on the force of gravity acting on that object, that's going to vary its weight. If we take a look at this picture, you can see there's a person standing on Earth and a person standing on the moon. But you can tell that though their mass is the same on both places, they both equal the same 50 kilograms, their weights are different. On Earth, they would have a weight of 490 newtons, but on the moon, 82. So why is this? Well, the moon is less massive than Earth, so its gravitational pull is much smaller than the gravitational pull of our Earth. In fact, it's 1/6 the size of Earth's gravitational pull. Okay, when we talk about an object that is in orbit, there's one force that is acting upon it, and that is the centripetal force that is caused from gravity. So the centripetal force is keeping one object in orbit around the other object, and that's due to the gravitational pull between those two objects. Remember that our Earth is a curved item. So if we take a look at this picture, we can see that, if we were to throw a ball a certain distance and a certain speed, then we would be able to follow the curve of our Earth, which would cause the item to be in orbit around our Earth. So if we were want to put a satellite or space shuttle or something in orbit around our Earth, we just have to launch it upward until it's above Earth's atmosphere so that it is at a constant speed to keep it to where it is falling around Earth. That same gravitational pull is affecting the astronauts that are up in the space shuttle. They're still having the effect of gravity on them. They just don't seem to be, they seem to be weightless up there. But that's just because they are falling around our Earth at the same rate as the shuttle is falling around our Earth. And so they're moving with the shuttle. Okay, let's next talk about the force of friction. So the force of friction is the force that resists the motion between two surfaces that are in contact together. This force is going to resist the sliding motion. Remember that friction is going to depend on how the surfaces of two items react to each other, whether they're going to stick together or they're going to slip and slide past each other. As the picture indicates, the motion of surfaces is going to change depending on the force that is behind the motion. You need a larger force to start something moving than you do to keep it moving. At first, the amount of friction that the item has is equal to the amount of force that you're applying to it. But at some point, the amount of force is going to overcome that friction. In this case, you're going to get acceleration and movement. Now, there is a force also that is pushing down on an object. So the harder the two surfaces are pushed together, the more difficult they are going to be for the surfaces to slide over each other. Now, the easiest way to get an object moving is to change the amount of friction, change these surface areas that are happening between the items. An example is if you take a look at this picture, again, where you're looking at the chairs. Well, if these are sliding across a very slick floor, like a wood floor or linoleum or something like that, then it's going to move much easier. If it's sliding across carpet, it's going to take a lot more force. And the last item I want to talk about is the friction that is due to air, which is called air resistance. So air resistance depends on the surface area and the speed of the object. An object with a larger surface area is going to come into contact with more molecules in the air as it moves than an object with a smaller surface area. This is going to increase your air resistance. So like our skydiver here, if he's wanting to go fast, he's going to put those arms in and he's going to get at least amount of surface area that is affected by the air molecules. If he wants to slow down, he's going to spread out in order to have greater surface area, which is going to disturb more air molecules, which is going to slow him down.